Hi everyone, I hope you're doing well. So in this video, we're going to discuss Leetcode problem of the day, and today's problem is house robber, and it is a medium level problem. So this is a very standard DP problem, and you while practicing DP or while learning DP, you would have encountered a similar problem many times. So what it says is there are n houses and you want to basically pick up some values from it, right? But the only condition is if you pick a current value, you cannot pick the value just adjacent to it. They have formulated this particular thing in some using some wording, and they say that each house has a theft system, and if you like broke into two adjacent houses, it will automatically inform the police. Now you don't want to alert the police, and hence you cannot take basically two adjacent elements, and you have to find the maximum value that you can find. So in this particular case, for example, you can take this particular 3 and this particular 1 and this particular 3, and the total value will be 4. So let us discuss how we can solve this problem. This is a very standard problem. If I don't go into the problem statement, it basically says that out of n values you have to maximize your sum, making sure that you don't pick two adjacent values, right? This is the only condition in this particular problem. So let us see how we can solve this problem. I am going to maintain a two-dimensional dp of n cross 2. Now what is each state going to denote? dp of I0 is going to denote the best answer starting from I, considering the last element was not taken, and dp of I1 is going to denote the best answer starting from I, considering the previous or the last element was taken, right? So these are the two dp states, and I am going to maintain, and at I is equals to n, if I consider 0 based indexing, all the elements will be from 0 to n minus 1, and if I reach the position n, that means this is my base case, and at this particular state I just have to return 0, because if I don't have any items, that means I cannot pick up any one of those, and my maximum sum will definitely be equal to 0. Now my answer should be in dp of 0 0, because I will be starting from position 0, and at position 0 I should not be having the constraint of picking or not picking this particular element, right? That means I have not taken any previous element if I am at position 0. So how are my transitions going to work? My transitions are going to work in this particular way. What you see is, let's say if I am at dp of I0, right? So that means I have not taken the previous element. If I decide to take, let's take current element. So dp of I0 is going to be the, let's say, cost of I plus dp of I plus 1 and 1. That basically means that I have taken the current element. If I take the current element I, my I plus 1 should be 1 here. Why? Because I have taken the element I, and this second part was denoting whether I have taken the previous element or not, right? This particular part. So let me just write the whole pseudocode first, and then you will be able to understand it better. So let's say we have a helper function with two values receiving int I and int j, and let's say we have this. So if I is equals to n, I am just going to return 0. If dp of ij is not equals to minus 1, that means I have already pre-computed this particular value. I am just going to return dp of ij, and then I have two options, either to take and either to not take this particular value, right? So both of them are initialized with 0 now. So if j is equals to 0, I can only take the current value if I have not taken the previous value, right? And if j is equals to 1, it is used to denote that I have taken the previous value, right? So only if j is equals to 0, I can try to take the current value. So let's say it is of cost I, and it is going to be helper of I plus 1 and 1. So basically what I am denoting is that if I have not taken the previous value, I can try to take it, right? And if I take it, I will get this particular cost, and the remaining answer will be from I plus 1, and I have to pass 1 with it, right? Why? Because if I have taken the ith element, the previous element from I plus 1 position will be taken, right? Now let's say I write no take, it is going to be helper of I plus 1 and 0, right. So basically if I do not take the current element for I plus 1, this j has to be 0 because I have not taken the ith element. Now I just have to return dp of ij is equals to maximum of take comma no take, right. So you see this is very simple, and at the end your answer will be a dp of 0 0. So this was all about this particular problem. If I just directly show you the code now, I have initialized a 2-dimensional array of size n plus 1 cross 2, right, and n is initialized with nums dot size. Now dp of n0 and dp of n1 both are going to be 0 because if I have exhausted all the elements I cannot find an answer, and the maximum value should be 0 only. Now we are just going to ignore these for loops for now and focus in the central part. So you see this is the exact same code that I have written. I have initialized take and no take both with 0 here, and then if j is equals to 0, I am just going to set take is equals to nums of I plus dp of I plus 1 1. So instead of just writing the helper function, I am just writing dp. Now no take is equals to dp of I plus 1 0, and dp of ij is going to be maximum of take comma no take. Now at all the positions you will realize that dp of I is depending upon dp of I plus 1. Now once we have like established this particular dependency, we know that we need to compute I plus 1 before computing I. That is why we have this reverse for loop at the top, so that all the values that are coming later are computed first, right. So n minus 1 will be computed before n minus 2, right. This is what we exactly wanted, and for the j loop it doesn't really matter, you can compute it in any order, and at the end we just have to return dp of 0 0. So let me just quickly submit this and show you that this particular code works and this solution is absolutely correct. So you see this passes all the test cases, and again you can make some optimizations, more specifically the space optimizations. You don't actually need to have all of this. What you can just essentially do is, so int 1 and int 0, right. So you can have two values like this. Since each state I is only depending upon the next state I plus 1, right. So I can denote the next state with only two variables. This is what I am trying to say. So this was it for this particular video. I hope that you guys were able to understand this solution, and if you guys did, then consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.